Hello students. So we all know IISc Bangalore has given us a sample paper. So in this video, I'm going to solve the questions which have been mentioned in the sample paper from IISc Bangalore. So this is related to the data science and artificial intelligence. So let us solve those questions. So before I solve, I can tell you that nearly 23 questions were given from the three topics: mathematics, from the three topics, that is probability, calculus and linear algebra. Out of the 55 questions mentioned, nearly 23 questions are from these three topics only. Now you can see the weightage from this topic. So I'm going to solve all the questions. So let's see how is the standard there. So I don't want, there is nothing like whatever questions you see they are going to appear. It's a reference for us. So these are the topics that they are going to touch. If you also cover these topics, you will definitely score in the upcoming DA paper. So let's start with the first question. The mean of the observations of the first 50 observations of a process is 12. If the 51st observation is 18, then the mean of the first 51 observations of the process is dash. So initially they say that there are 50 observations, their mean is given. They add a new observation, so the observations are now 51. What is the mean of the new observation? So that's what is asked. Let's write like this. So let us assume that x1, x2 up to, let's say, x50 be the observations. So what they gave is the mean of the first 50 observations is 12. So they gave this information that x1 plus x2 plus so on plus x50 by, because sum of the observations, by number of observations. They gave that this is equal to how much? It is 12. And if you add one more observation, which is like 51st observation, what is the new mean? So how do you find that? For that, let us send this to this side. So we have now x1 plus x2 plus so on plus x50 equal to 12 into 50. So 12 into 50 is, I think, 600. Use your calculators to verify this. So what next? So what is a new observation? Did they say anything about the new observation? Yes. The new observation that is added is 18. So let us find the mean of the 51 observations. So what we usually do is, to find the mean, we write like this. So it's x1 plus x2 plus so on plus x50 and the new observation. So what's the new observation? Okay, let's write this as x51 and then divided by the number of observations, that is 51. This is what you have to find. Now this new ratio you have to find. Now from the previous data, we understood that x1 plus x2 plus up to x50 is 600. So you can utilize that information there. So it is 600, because I'll highlight this with another color. You can check this. Do you know how much is this? From our previous observation, this value is 600. So that's what is substituted here. It's 600 plus, what's the new observation? The new observation is 18 and the total number of observations are 51. So it is 618 by 51. Approximately it is 12.12. You can use your calculators and check this. Approximately 12.12 is the answer. Let's go to the next problem. In this problem, they say that a fair coin is flipped twice and it is known that at least one tail is observed. So already some condition has been mentioned. So they have a fair coin, they have tossed it 2 times and it is known that at least one tail is observed. The probability of getting 2 tails is, so what's the probability of getting 2 tails? Okay, so let's solve this. Now when you toss a coin 2 times, what's the sample space? The sample space is like this: head, 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 tail, tail, head, and then tail, tail. This is the sample space. Now he's saying that a coin is tossed in such a way that at least one observation is tail. So look at this, at least one tail is observed. So let's write the reduced sample space. So what's the reduced sample space? You need to select those points from this in which there is at least one tail. So the reduced sample space is like this. This doesn't come here because both are heads. Yes, at least one is head. So this can be covered here. This can be covered. And this will also be covered. This is the reduced sample space. Now whatever outcomes you get only from this set. You can forget about the original sample space. Just focus only on this. So now what else they are asking? The probability of getting two tails is. Now from this, what's the probability of getting two tails? Now what's the favorable point? Let's highlight our favorable point. This is the favorable point among the three. So what could be the probability of this? So it is obviously the number of favorable points by the total number of points in this set. Don't look at the sample space because it's already given that at least one tail is observed. So now this is your reduced sample space. Therefore, the required answer, look at this, how simple is this? The required answer is simply the one favorable point by 3. So do we have such options? Yes, it's 1 by 3. Clearly a very simple problem based on conditional probability. So look at this one. This is not that easy. This was one of the nice problems that we have observed in the sample question paper. So let us read this problem. So what do they say? Given n indistinguishable particles. What do you mean by indistinguishable? Indistinguishable means you are unable to find the difference, or in simple words, there are whatever particles have been given, they are identical particles. Given n indistinguishable particles and m, which is a number greater than n, distinguishable boxes. So m is a we have got m different boxes, distinguishables. There is a clear difference in those boxes, or in simple words, whatever boxes you have, they are all different from each other. You have m different boxes. We place, so this n distinguishable particles are placed into those n indistinguishable particles are placed in m distinguishable boxes. We place at random each particle in one of the boxes. The probability that in n pre-selected boxes, one and only one particle will be found is. So let us try to understand the question. Let's see what's the solution for this. A very good problem. Already in discrete mathematics also you would have covered. So where you have got indistinguishable objects placed in distinguishable boxes. You would have studied this under a special case. In discrete mathematics, there is a separate topic called combinatorics. You would have studied in that as well. But let us solve this. So how do you solve? First of all, please understand that there are n indistinguishable particles and m distinguishable boxes. So let us write something like this. Let x1, x2 up to, let's say, xm be the number of particles placed in those m distinguishable boxes, placed in m boxes respectively. So what do you mean by this? So we have got m boxes, students, 1, 2 up to m boxes. So what is this x1? So x1 is the number of objects that we have placed. So what we usually do is take one object, put it in any of the box now. Take another object, you put it in any of the box, right? That's what he says. So finally, after you put all those objects into the boxes, so each box will contain certain number of elements. So now what is this x1? x1 is the number of elements in the box 1. What is x2? x2 is the number of elements that we have placed in box 2. Similarly, xm is the number of elements that are placed in mth box, because there are m boxes. Now we get a condition that, look, x1 plus x2 plus so on plus xm. Now when you add all the objects, objects means, so x1 number of objects were placed in the first box, x2 were placed in the second box, xm were placed in the mth box. So when you add all this, obviously you have to get the total number of particles or total number of objects. The total number of objects given to us are n. Now this equation is a very important reference equation for us. x1 plus x2 plus so on xm will be equal to what? N. Now let me ask you, what are the total ways in which I can place this n objects into those m boxes, where these objects are identical whereas the boxes are different from each other. So I can place all those n objects into the first box or into the second box and so on. So when you place all the n objects, for example I'm saying, if you place all the n objects into the first box, then you know what kind of solution you get. Let me solve it in the next page. So suppose you put all the objects in the first box and all the remaining in all the remaining boxes no objects at all. So when you add, is this giving n? Yes, this is one such solution. Now how many such solutions are there? In how many ways I can place those n indistinguishable objects into those m different boxes? That's the question. So if you examine this carefully, so I have an equation where I have m variables. So when I add all of them, so I'm looking at, so shall I take integer solutions or non-integer solutions? So here look at this, 0 is also left. So you can take non-negative integer solutions, because 0 is also left here. You can look at what? Non-negative integer solutions. So I usually explain this concept. Suppose you have x1 plus x2 plus so on plus xr, let's say equal to n. So how many non-negative integer solutions are possible? So the number of non-negative integer solutions are n plus r minus 1 c r minus 1. These many non-negative integer solutions are possible for this equation. So we also have the same equation here. The only difference is in the place of r we have m. So how many total possibilities are there where I can distribute those n particles, n identical particles into those m different boxes? So the answer, so this is not the final answer by the way, it is just an intermediate answer. I'm just writing the total ways. So the total ways are, so if you want to the total ways, then you have to look at this solution. So it is n plus m minus 1 c m minus 1. You can simplify this result. This is something like NCR form. What is NCR? N factorial by r factorial into n minus r factorial. That is n plus m minus 1 factorial by m minus 1 factorial into n minus r, that is n plus m minus 1 minus m and then plus 1, because you have to subtract these two quantities. Something like this whole thing can be treated as n, this whole thing as r, so it is n minus r factorial. So when I subtract, this is what I get. Any cancellation? Let's see. Yes, they get cancelled. So what is left? The leftover answer you try to write here, m n plus, okay, so it doesn't matter. So it is n plus m minus 1 factorial whole divided by m minus 1 factorial into n factorial. This is the total number of ways of placing those n indistinguishable objects into those m different boxes. We are not yet done. This is the total number of ways. That means when you try to find the probability, in the denominator you will see this term. Now what's the question? The probability that in n pre-selected boxes, one and only one particle will be found is. So this is quite confusing as well. When I read this, I took some time in understanding what exactly is this statement. He says that when you select n boxes, what's the probability that in each box exactly one object is there? So that's the question. So we found the total ways. Now we need the favorable or the Yes, we need the favorable cases. If you can comment on the favorable cases, the answer is favorable cases by total number of cases. So how do you comment about the favorable cases? So let's see this 1, 2 up to let's say m. So let's write them 1, 2 so on up to m. There are m boxes. He says if you select n boxes, in each box there must be exactly one element. So in how many ways you will have that? You will have exactly one way of doing that. So what do you mean by that, students? So this is quite confusing. It took some time for me to decode. So he says that he has selected n boxes, and in all those n boxes, in every box there must be exactly one element. So in how many ways you can have that? Exactly one way, because the objects are identical, students. You think this is not that easy. Just I cannot simply complete this and go. You select those n boxes, you have those n objects. In how many ways? In different ways you can place them such that in each box there is exactly one element. For example, I'll show. So let's say I've selected the first n. So let's say because m is greater than n. So let's say this is the nth box, students. This is nth box. Let's say I've selected this. I've selected this. Let's say you have placed objects here, objects here, objects here. Since objects are identical, students, are the objects identical? Yes. So in the first time what I've done is I've placed the first object here, second object into this, nth object into the nth box. Even if you interchange this, again that is going to be identical because the objects are identical. Whether you place this here or this, it doesn't give you a new combination. It doesn't give you a new combination. So if you have pre-selected n boxes, the number of ways in which you can have exactly one element in each box. So this is also important. In every box there is only one element. So whether you place this element here or this element here, it doesn't matter because objects are identical. So you can do this only in one way. So the favorable cases are only one. So what's the answer? So let's write the answer here. So the answer is only one way, because out of those n, there are n boxes, student, because you have selected n boxes, and the probability of having exactly one in every box, this can be done in only one way, students. This can be done because already those n boxes are selected. The probability of having one element in every box, this can be done only in one way. Now you cannot say, sir, so let me just show you what's happening here. Let's say there is object. Since all objects are identical, I can't name them. So even if you interchange, this looks the same. The reason is that objects are identical. So what's the answer? It's 1 by the total number of ways. The total number of ways are n plus m minus 1 factorial divided by what? N factorial into m minus 1 factorial. This quantity goes to the numerator. So now what we get is n factorial into m minus 1 factorial and then whole divided by n plus m minus 1 factorial. So a brilliant question that was asked. So what's the answer? Do we have any options matching that way? Yes, we have this option B. So already those n boxes are pre-selected, it seems. Now already the boxes are selected. So in those boxes, in those n boxes, exactly one object must be there in each of the box. So you can do that in only one way, students. Boxes are already selected, n boxes. See the probability that in n pre-selected boxes, one and only one particle will be found. So here the question should have been given this way. One and only one particle in each box. If they would have said that, it would be even more good or even more elegant way of understanding it. So it should have been given one and only one particle in each box be found as dash. So this is how you solve it. Initially I couldn't understand what is the meaning of one and only one particle. Then I through the options. So sometimes options, you look at the options and then try to do the reverse engineering. Then I understood that okay. So he has already pre-selected n boxes. He wants one and only one object in each box. which can be done in only one way, and the total number of ways are this. So 1 by the total number of ways I matched with the answer. They have not provided the key also to verify. It's all about the understanding and then verifying the options. So concept wise there is nothing wrong. x1 plus x2 plus xm equal to n. So how many non-negative integer solutions are there? Then it is n plus m minus 1, c m minus 1 solutions are there, and the favorable cases are exactly 1. So with that we get option B. So it was a difficult question actually. So let's look at this. For two events A and B, where B is a subset of A, which of the following statements is correct? It's a MCQ student, multiple choice, not MSQ. They gave various options. So let's solve this. So let's create a sample space. Let's say this is the sample space. Let's say there is an event called A. Let's say event called B. Now why did you draw B in the set A? Because if you draw it like this, clearly B is a subset of A. So B is a subset of what? A. So that condition is satisfied. So this is the sample space, students. So what next? We have to verify the various options. So let me verify various options. Before that, so clearly B is a subset of A. Now tell me, what is A intersection B? What is A intersection B? What's the common part of A and B? The common part of A and B is clearly, let's apply probability on both sides. The probability of A intersection B will be exactly probability of B. Let's take this term to the other side. So the probability of A intersection B by probability of B. Because you are bringing this term here, so what is left is just 1. If you carefully observe, probability of A intersection B by probability of B, this is nothing but a definition of the conditional probability. So what is this? This is simply probability of A given B, which is 1. Now you can verify the options. We got the conditional probability of A given B as 1. This fellow says less than 1. You can remove this. We got this as 1, but this fellow says 0. You can remove this. So this is the first conclusion. We eliminated 2 of the options. We are now left with few more. So we are left with few more operations or few more verification. So what is that verification, students? So here we looked at probability of A given B. Okay. Option A and B talk about B given A. So let's see what is this. What's probability of B given A? So by the definition, it is probability of A intersection B by probability of A. Okay, so the numerator, which is A intersection B, what is A intersection B from this? It is simply P of B. So this is what we have so far. So what is this, students? This is the conditional probability of B given A, which is now P of B by P of A. And now I have to compare this with P of B. Is this quantity big or P of B big? That's what I have to compare. So I'll write one more quantity here for comparison. This is also one of the good problems. Let's compare this with P of B. Now look at this. This fellow is equal to this. I want to compare this fellow with this fellow. See who is bigger. Is this bigger or this bigger? So you might be confused with these things. Okay. So let's look at this. What's the difference between this and this? The difference is that in the denominator we have P of A. Sometimes you might do a mistake. Look, what is P of A? P of A is something which is between 0 and 1. Right? The probability of any event will be from 0 to 1. For example, P of A equal to 0.5 would be good. Okay, 0.5. You can take any value between 0 and 1, no issues. If you take P of A as 0.5 is same as 1 by 2. So I'm just saying what happens if I take P of A as 0.5, which is 1 by 2. So you now have to write P of B by 1 by 2. That 2 goes to the numerator and this will now look like 2 into P of B. That means what I want to say is, if you compare this with this fellow is always greater than or equal to this fellow. Sir, why sir you are dividing as a we are dividing, but with what number are you dividing? Is it greater than 1? No. the probability can never be greater than 1. So this quantity is always between 0 and 1. So because of this, this ratio will now be bigger than this. So now what can you say is, this by this is always like this. This fellow is greater than or equal to this. Do we have any option saying the probability of B given A greater than or equal to B of B? Yes. This is wrong and this is the right relation. Now some students are still confused. Sir, why did you put 0.5? Sir, I'll put 5, sir. How can you put 5, sir? This is P of A. Probability of any event will not be more than 1. Now try with some other values. So you try with any other value between 0 and 1, then this ratio will be more than this. And there is only one such relation in the option, which is option A. I hope this was clear, this was easy. So this is another question on conditional probability. Earlier also there was a question on conditional probability. Look, they gave importance to conditional probability. You have to be a little clear with that. So let's look at this question. X is uniform distribution random variable with support in -2 to 2 union 99.5 comma 100.5. The mean of X is. This is very simple question. He says that X is uniformly distributed in this interval as well as in this interval. So union means X takes values from these set as well as from this set. So he's asking what is the mean of X. Students, if X is a uniform random variable in the interval A to B, if X is uniform, then the mean is given by simply B plus A by 2 or A plus B by 2, doesn't matter. So X takes values from this interval as well as this interval, and by the way, it's a uniform random variable. Uniform random variables, the mean is A plus B by 2. What you can do is, you find the mean by taking this interval, you find the mean by taking this interval and you add the things. That will be the new mean. So the mean is, what is the mean related to this interval? You can use B plus A by 2, that is 2 plus minus 2 by 2 plus. Now you might be saying, sir, why you want to add? Because X is taking values from this interval as well as from this interval. That's why you have to add it. Okay. And then 100.5 plus 99.5 by 2. So this is anyway 0 plus, how much is this? Is it 200 by 2? Yes. Therefore 200 by 2 is 100. So the mean of X, which takes values in the interval -2 to 2 and from 99.5 to 100.5, is simply 100. The Pearson's correlation coefficient between X and Y rounded to the first decimal point for the given data in below table is dash. They gave some observations, X observations and the corresponding Y observations. They want the Pearson's correlation coefficient. So we know that this correlation concept is given in data science and artificial intelligence paper. How do you find the correlation coefficient? So what is the expression for the correlation coefficient? Let me show you. This is going to be a lengthy problem. What I feel is, the reason for giving this is, so they want to say that, okay, we are going to ask you the questions related to correlation coefficient and their properties. It's a lengthy problem. So I'll show you what is the expression for the correlation coefficient. The expression for the correlation coefficient is covariance of X comma Y by sigma X into sigma Y. This is the expression. Now how do you find the covariance? The covariance, you can find it like this: expectation of xy minus expectation of x into expectation of y. This is one way. There is also another way. Whenever the table are given, you can also find it like this. It is expectation of x minus x bar into y minus y bar. So we usually use this because the calculations would be simple. And you know what is sigma x, standard deviation of x, sigma y, standard deviation of y. You have to find all this and then substitute into this. So it's a lengthy problem. Maybe they might ask you properties of correlation coefficient in the coming examination. What I've done is, I created a table where I'll write x, I'll write y, and I will also make sure that I'll find the variance of x. We will also find variance of y, and then the covariance, and then all these values substitute into this to get the answer. It's a detailed process. So look at this. This many calculations are involved. First, I have taken x and then written the same data y. You can see this same data I have copied here. And then this is x bar, students. What is this? This is x bar. X bar means mean of all x observations. Y bar means mean of all y observations. How do you find the mean? You add all these observations and divide by the number of observations. For example, add all this and then divide by 1, 2, 3, 4, 5. Divide by 5. Add all this, divide by 5. So I have got this. First thing is you have to find mean of x and mean of y. What next? The focus is on average of x minus x bar into y minus y bar. So first get x minus x bar observations, y minus y bar observations, you multiply them and then take average of that. So I'll show you how to do that. And what is sigma x? So before that, what is variance of x? You all know the variance of x as this: expected value of x square minus expected value of x whole square. So this is what you know. You can also find it in the following way. So what is it following way? You can find it like this. It is expected value of x minus so let me write it properly. So expected value of x and then whole square. So what we usually do is we subtract mean from x, we square it and then average it. So the one who is familiar with this will understand. If you have to find this, it might be a little lengthy with this table, but if you find this, it would be easy. You can also write this as expected value of x minus x bar and then whole square. Look, there is x minus x bar. Here also there is x minus x bar. Similarly, you will also use y minus y bar. So it's better we use this approach to avoid big calculations. As usual, I wrote x, their mean, y, their mean. I have calculated x minus x bar. How do you find x minus x bar? Look at this observation. This is minus 6. So it is minus 6 minus of minus 0.16. I'll just show you how I have got the first element. It's like this: minus 6 minus x bar. What is x bar? Minus 0.16. If you use your calculator, you will get the answer as minus 5.84. So like this, you have to fill all these elements and then find y minus y bar. How do you find y minus y bar? This is a y observation and mean of this is 4.9. So for example, how did I get this? You have to do it like this: 6.4 minus 4.9. So if you do that, you get 1.5. Like that, 4.7 minus 4.9, which is minus 0.2. 8 minus 4.9 and so on. You have to fill this data. And then take square of these. Square of this. I have squared minus 5.84 whole square is this much. 2.16 square is this much and so on. I have squared all of them. After squaring, I have averaged all this. Average in the sense, you add all this and then divide by 5. When you add all this and divide by 5, this is what I got: 20.98176 approximately. Similarly, you take square of this. This is what is written, and then you average. Average means add all this and divide by 5. I added all of them and divided by 5. I got 4.512. If you carefully observe, this is nothing but the variance of x. This is nothing but the variance of y. So we have variance of x, variance of y. If you know the variance, you can find the standard deviation by simply taking the square root of this, square root of this. Now you should also find x minus x bar into y minus y bar. For that, you have to multiply this and this. I have multiplied. So we have done the multiplication. And then add all this, divide by 5, because I have to average them. So if you do this, you get the covariance minus 4.616. So covariance, look, you can find the covariance either like this or this way. So I calculated this, then E stands for the average. So add all this, divide by 5, I got this. So I have the covariance. I got sigma x square and sigma y square. I substituted into this formula. So the formula is covariance of x comma y by sigma x sigma y. I have to find sigma x and sigma y. Sigma x is the square root of 20.98178. So I have done that. Sigma y is the square root of 4.512. So I have done that. Substituted those expressions. When you look at this ratio, approximately I got minus 0.5 as the answer. Okay, minus 0.5. Do we have such options? Yes, we have such options. This was a lengthy problem. We can expect properties of correlation coefficient. We can also expect properties of regression coefficients in DA 2024 coming paper. So now look at this question. He says X is a uniformly distributed random variable from 0 to 1. So it's missing here 0 to 1, print mistake. X is uniformly distributed from 0 to 1 and its density function is 1 whenever X is between 0 and 1 and it's 0 otherwise. What is variance of X? It's a very simple question. Suppose you have X to be uniformly distributed in the interval, let's say A to B. So it's a standard result, students. What is variance? So the variance of X is, it is B minus A whole square by 12. In the present problem, he says X is uniformly distributed in the interval 0 to 1. So that means the value of A is 0, the value of B is 1. You can substitute into this variance formula, which is 1 minus 0 whole square by 12, which is 1 by 12. So we have that option here. This is the right answer. This is a question which is based on joint distribution function. So they have clearly mentioned about joint distribution, and there is a question in the sample paper also. So let's see what is this question. Consider the following joint distribution of random variables x and y. So the joint PDF is given as x into 1 plus 3x square by 4, where x is from 0 to 2 and y is from 0 to 1. So we usually write this small f for the joint density function, students. Okay, joint PDF we say. Which one or more of the following statements are correct? He has created in the sample paper a MSQ. So for sure they'll ask you MSQ as well. So please be clear with that. And the options are x and y are mutually uncorrelated, x and y are mutually independent, the mean of x is 1, the mean of y is 0.5. So we need to find all this. So to find all this, the best way is first find the marginal density functions. First find the marginals. So how do you find the marginal density function of x? We usually denote this with fx of small x, which is given by. So how do you find the marginal density function of x? So we need to perform the integration for all the values of y here. So what is y limits? Y limits are 0 to 1. So y from 0 to 1, you need to integrate the joint density function, which is f of x comma y with respect to what? Y. So let's do this. Y is from 0 to 1. Now what is your joint density function? It is small x into 1 plus 3 y square by 4 dy. While performing this integration, you have to treat x as constant. So just integrate the y terms and then see what's the final answer. So you can put x by 4 out. So what is left here? 1 dy. So what is integration of 1 dy? It is y plus. What is integration of 3y square? It is 3y cube by 3. And what are the limits of y? 0 to 1. So now after substituting the limits, anyway this 3 cancels. When you put the upper limit, 1 plus 1 cube is 2. So 2x by 4 is x by 2. So finally I have the marginal density function of x, which is x by 2. But this is valid only in the interval 0 to 2. So let's write like this: 0 less than or equal to x less than or equal to 2, and it is 0 otherwise. So I got the marginal density function. If you have the marginal density function, you can also find the mean. So how do you find the mean? The mean of x is integration over all the values of x. Since x is only from 0 to 2, you can write like this: 0 to 2. It is x fx of x. That means you all know the mean is like integration x f of x dx. You need to substitute the marginal density function here. So it's 0 to x into, what's the marginal density function? It is x by 2 and then dx. So x into x is x square. When you integrate that, you get x cube by 3. So this is x cube by, so there is a 2 and in addition to that you will get a 3 and the limits are 0 to 2. So substituting the limits will give you 8 by 2 into 3, lower limit is 0. So which is how much? 4 by 3. What is the mean? The mean of x I have got as 4 by 3, but he says it is 1, which is a false statement. What are we supposed to do? Which of is correct, but this is a false one. Likewise, get the marginal density function of y, find its mean. Fy of y is for all the values of x. So within all the limits of x, which is from 0 to 2. So you have to write it clearly. Where x is from 0 to 2, you have to integrate the joint density function. So what's the joint density function? With respect to what? X. So let us integrate that. X is from 0 to 2. The joint density function is x into 1 plus 3 y square by 4. This integration is now with respect to x. You can treat 1 plus 3y square by 4 as a constant, you can put that out. So 1 plus 3y square by 4 is like a constant, you have to treat that way. 0 to 2, what is left is simply x dx. Integrate it, substitute the limits, what's the final answer? So the marginal density function, probability density function of y is integration of x is x square by 2, correct, x square by 2. So this is 1 plus 3 y square by 4 into x square by what? 2, x square by 2, and the limits are 0 to 2. So after substituting, here you will get 4 and there is a 4. 4 cancels, but this 2 will be left over. So I have the marginal density function of y now. So what is that? It is 1 plus 3 y square by 2. But this is valid only in this limit of y, that is y from 0 to 1, and it is 0 elsewhere, or in other interval it is 0. So I've got the marginal density function of y. Now we need to find the mean of y. It is so simple, students. How to find the mean? Just like the way we calculated earlier. So the mean of y is integral y is from 0 to 1. It is y into the marginal density function. So what's the marginal density function? 1 plus 3 y square by what? 2, and then dy. So just complete this integration process. Let us complete this integration process. You want me to do in the next page? I'll go to the next page. So expected value of y. So what is this? First term is y plus second term is 3y cube, and then do the integration. 1 by 2 is out, 0 to 1. Complete this integration process. So it is 1 by 2. This is y square by 2 plus this is, okay, y into y is y cube. See, I have done a mistake here. So I should have written y cube here. This is y cube. So the integration of y cube is y power 4 by 4. Now substitute the limits, which is from 0 to 1. So we need to simplify this. 1 by 2 into, this is 1 by 2 plus 3 by 4. Complete this simplification process. So 2 goes here, 2 plus 3 is 5, 5 by 2 here, and the LCM of this is 4. So it is 5 by 8. The mean of y is 5 by 8. But in the problem is 0.5. Nowhere 5 by 8 will be equal to 0.5. It is a false statement, students. Now we are left with option A and B. I can even solve that. So I'll show you how to solve that. So let's check this. Students, what is F or the joint PDF? The joint PDF was given as, so it is like this na, x into 1 plus 3y square whole divided by 4. So x is from 0 to 2 and y was from 0 to 1. Now what were the marginal density function, students? What was fx of x? Write it, fx of x. It is x by 2, okay. I'll just write their expressions, x by 2 in the same interval, students, in the same interval. What was fy of y? Fy of y we have just calculated here, fy of y, where is this? 1 plus 3y square by 2. 1 plus 3y square by 2. Now if you want to know whether they are independent or not, then what you do is you find the product fx of x and fy of y product. So this is like x by 2 into 1 plus 3y square by 2. How much is this? This is clearly x into 1 plus 3y square by 4. See here, x into 1 plus 3y square by 4 is nothing but f of x comma y. So finally we have a condition that f of x comma y is simply fx of x into fy of y. Whenever your joint PDF is product of individual marginal density functions, clearly x and y are independent. They are mutually independent. So this is a true statement. Now when they are independent, obviously they are uncorrelated as well, because if two random variables, let's say, are mutually independent, then obviously they will be uncorrelated. So the other way need not be true. What is the other way? If they are mutually uncorrelated, they may not be independent. But since we found that they are independent for sure, they must be mutually uncorrelated as well. So this is also true. Now how many correct answers are there? So this question has got two correct answers. One is A, other is B. So this comes under what? This comes under MSQ. MSQ will have one or more than one correct answers. So you can go through this. It was a very lengthy question actually. So let's look at this question. So what do they say here? They gave some sample points like O1, O2, O3, O4 represents the outcome of an random experiment, it seems. With probability of O1 exactly same as probability of O2, same as probability of O3, same as probability of O4, meaning by they are equally likely sample points. So all of them are, the probabilities are same. So obviously it has to be equal to what? 1 by 4. Since there are 4 points and 4 are equally likely, the probability has to be equal to 1 by 4. And then he says there are some sets called P which contains points O1, O2. There is a set called Q which contains O2, O3. There is a set called R, O3, O4. There is a set called S which contains O1, O2, O3. Then which of the following statements is true? P and Q are independent, P and Q are not independent, R and S are independent, Q and S are not independent. So let us verify this. This doesn't look like a MSQ here, because which one of the following statements is true is said. Suppose if the question was which of the following statements are true, then it's a MSQ. So now it is MCQ. So let's see how to solve this question. I'll go with the options actually. I'll go with the options. So first let us look at P. What are the elements in P? O1 and O2. O1, O2. What is probability of this set called P? Since there are 2 points and total are 4, it is 2 by 4, which is 1 by 2. Now what is Q? I'll write them directly. What is Q? Q contains 2 points O2, O3. So Q contains O2 and O3. What is probability of Q, students? It is also 2 by 4, which is 1 by 2. So what next? I should also find the intersection of P and Q. So what are the common elements of P and Q? So is there any common element, students? there is O2 here and there is O2 here. So there is a common part which is O2. Now try to answer this. What is probability of P intersection Q? How many points are there in the set? 1 and total are 4. So this is what we get. Now how do you check whether they are independent or not? How do you check whether they are independent or not? Simply you have to check this. What is probability of the set P into probability of the set Q? If this product is equal to the product of intersection, if this product is equal to the probability of their intersection, then they are independent. So what is the probability of the event P? It was 1 by 2 into what is the probability of Q? It was also 1 by 2. So how much is this? This is 1 by 4. Is this product equal to the probability of their intersection? Yes, therefore they are independent. They are independent. So I can now say that P and Q are independent. So this is our correct answer. Since option A is correct, option B has to be wrong. P and Q are not independent is the negation of this. This is gone. Since it's a MCQ, this CD should also be wrong. So we will analyze, since we are learning, let us analyze C and D. In C and D, they talk about R and S to be independent. So what is R? What is R, students? R, where is R? O3, O4. Okay. O3, O4. What is probability of R? It is 2 by 4. There are 2 points and total are 4. So which is 1 by 2. Is talking about S. What is S? 1, 2, 3. S is O1, O2, O3. What is probability of S? How many points are there? 3. Total are 4. So it's 3 by 4. Now what is their intersection, students? S or P intersection S? Both are same. Whether you write not P, sorry, it is R intersection S. What is R intersection S? O3. O3. So students, what is probability of R intersection S? How many points are there here? Only 1 divided by 4. Now the same way, what is the probability of R into probability of S? If you take their product, it must be equal to 1 by 4. Is it? Let's see. What are the individual probabilities? One is 1 by 2, the other is 3 by 4. Correct? 3 by 4. So this is 3 by 8. So clearly we found that probability of R intersection S is not equal to the probability of R into probability of S. Now when this condition is satisfied, then R and S said to be independent, but here R and S are not independent. So they are not independent. This is gone. Likewise, you can eliminate D as well. So I'll show you how to eliminate D. Now what are the points in Q? What are the points in Q? Q. Where is Q? Q is O2, O3. O2, O3. What is their probability, students? P of Q, which is clearly 2 by 4, which is 1 by. Next, S. What is S? 1, 2, 3. S is O1, O2, O3. What is their probability, students? What's probability of S? It is 3 by 4. So earlier we have analyzed R and S, now it is Q and S, students. So what is their intersection? Intersection of S and Q. Is there any intersection? Of course there is an intersection. So the points are O2 and O3. What is probability of this? What is probability of this? So there are 2 points and the total points are 4. In this set there are 2 points and total points are 4. So which is 1 by 2. Now what you check is, what is probability of Q into probability of S? If this product is equal to 1 by 2, then these 2 events are said to be independent, students. So what is probability of Q? It was 1 by 2 into, what's the probability of S? It was 3 by 4, which is giving you the answer as 3 by 8. Nowhere this 3 by 8 is equal to 1 by 2. So they are not independent. What we got is something like this. What we got is something like this. P of S intersection Q is not equal to P of S into P of Q, meaning by they are not independent. So where are we? We are talking about Q and S. Yes, they are not independent. So if it is a multiple select question, so then which of the following statements, statement or statements, so they should have given like this, statements or statements. Q and S are not independent. Yes, that's what I got. Maybe initially I said it as MCQ, but after clearly which of the following statements he says. So this D turns out to be a true statement. So yes. So please correct my statement earlier. I said it was a MCQ, no? Which of the following statements? They should have given it clearly, putting in the bracket. Maybe from my side was a typing mistake. So finally, yes, Q and S are not independent, whereas P and Q are independent. There are multiple answers for this. It is option A and D. Students, technically there is no mistake in whatever I have solved. Maybe while reading, I said it's a MCQ. Okay, so let me put S in the bracket. Which of the following statement or statements is are true? So option A is true. Option D is also true. So let us look at this question. A class contains 60% students who are incapable of changing their opinions about anything, and 40% of the students are changing their minds at random with probability 0.3 between subsequent votes on the same issue. Then the probability of a student randomly chosen voted twice in the same way is. So let's see how to solve this. You can imagine that there are 100 students in a class, and you can also think of a election here. So in our state recently we have completed the election, so you can compare this with that election kind of thing. So let's say that there are 100 students in a class. 60% of the students are incapable of changing their opinion about anything. So there are 60% here, like there are 60 students who don't change their opinions, okay, about anything, like whatever may be the issue, they are sticking to the same answer. Or you can think, like, let's say they have voted to the party called X. So even if they have given another chance to vote, let's say you have gone for the elections, you have voted. Suppose if I given you another chance for the voting, so 60% of the students, they don't change their opinion. Again, they vote for the party called X. That's what is given. And the 40% of the students are changing their minds at random with probability 0.3 between the subsequent votes on the same issue. So there are 40% students who change their opinion. So let me talk about this in a detailed way. There are 40% students who are changing their minds with probability 0.3. So what is the meaning of this? In this 40%, with probability 0.3, they are changing their opinion. So what is probability 0.3 means? It's a 30%. Okay, so what is the 30% of this 40? So you just multiply this 40 with 0.3. If you multiply 40 with 0.3, so you will get 12. So if there are 100 students, then among them there are 12 students who change their opinion after voting. That's what it means. So in this 40, you can now say that, so 12 if you subtract, there are 28 people who do not change their opinion in this category. Then the probability of a student randomly chosen voted twice in the same way is. So you can think of, let's say you have gone for the election, you have voted. Suppose it's a hypothetical thing. Suppose if you are given a chance again to vote, so you have gone in the morning, let's say next day again you are given a chance to vote it again. So what's the probability that a student chosen at random voted twice to the same party? So twice to the same party, that's what we have to answer. So what I will do is, so it's a one-step answer, students. Look at the answer. I hope everyone has understood this. There are 100 students in which there are 60 students who do not change their opinion. So 60% students who are incapable of changing their opinion. That means on a given day, if they have voted to a party called X, next day, if I again conduct the election, again they have voted to the same X. That means these 60% students have voted in a same way. This is not the only way. This is not the only way. So now what I would like to say is, if you want to find the probability of a student chosen randomly voted twice in the same way, obviously this 60 students have voted in the same way. So it is 60% means it is 0.6 plus. So we have something else here. Now there are remaining 40% students who change their minds at random with probability 0.3. So what do we mean by with probability 0.3? For example, from these students, there are 12 students. For example, today if they have voted for the party called X, then tomorrow if again elections are held, they'll vote for a party called Y. But look at this category. Among these 40 persons who change their opinion, there are people in this category also where if they voted for X today, tomorrow also these people are going to vote for the same party called X. So what percentage? It is 28. So you can, if you say 28, so what you can do is, you can do it in many ways. So what is 28 in terms of percentage? It is 0.28. This is one way of solving. So this is 0.6 plus 0.28. How much is this? It is 0.88. So there are total 88 students out of 100 students who vote in the same way. This is one way of solving. You can also solve it like this. Even then you get the same answer. So if you select any of the students, they will vote in the same way. So the probability of choosing them is 0.6 plus. What next? 40% are there. So 40% means 0.4. Now you have to be a little careful. In this, there are students who change their opinion with probability 0.3. If students change opinion with probability 0.3, then what's the probability of students not changing their opinion? It is 0.7 students. It is 0.7. So if they have voted now for X, then tomorrow also they'll vote for X. So that probability is 0.7. So if you simplify again, you get the same answer, that is 0.6 plus 0.28, which is 0.88. So finally, the probability of a student randomly chosen voted twice in the same way is 0.88 is the answer for this question.